All right, I'm going to try to make this video short. Uh, this is a command radio power supply. I've showed you that in the past. I had very good luck with it. I take a 24 volt transformer, which goes to the filaments and lights the filaments, and then from a center tap in one side of the transformer, I power this transformer backwards, and then that goes into a full wave rectifier, and that creates 120 volts DC. Okay, nice little compact. It all just seemed to work out. So then I went and made a bigger power supply for a BC348, and I noticed the one transformer was getting exceptionally hot. I was overrunning it. I got my current meter out, my AC current meter out, and I put it in series with the winding, and I just couldn't get what I expected to get. And here's the transformers that don't work good. These are Radio Shacks. I got a billion of these things, okay? I had them actually go bad in the package where they like rotted away, so I had to take them apart and repaint them. But I got a lot of them, and I have them at 6.3s, 12 volt ones. I got, let's see, the other one is 18 volt ones. I have 24 volt ones. And here's the trick. Now, it's called backfeeding, or putting a transformer backwards to another transformer and stepping the voltage back up. So in this case, we used the step down from 110 to 24 to light the filaments. Then we would do a reverse, or backfeeding, and we step the voltage back up, and it's isolated from the line, and we go through a rectifier and we get 120 volts DC. All worked out, nice little package, just drops on the back of a command radio. So now we want to power a BC348, and all hell breaks loose. Here's why. I'm going to get right to it. I'm not going to go on and on and on and on. If you go reading, and you're going to have to really dig, and the word is backfeeding, I'm pretty sure I'm remembering it correctly. This transformer is wound. So let's see what the voltage is on this one. All right, so this one is 6.30, 6.3. It's a 12 volt, 12.6 volt transformer. Okay? It's wound in such a way that under the current this is rated at, let's see what the current is rated at. Can I see that too? Okay, 3 amps. The current this is rated at 3 amps, the voltage on this transformer will be 12.6. This is not a transformer that likes to be backfed, okay? You're going to have all kinds of losses, right? Because it's not made to be backfed. Now, I found a file, and it was a Hammond company. I don't know if it's Hammond Oregon company, Hammond transformer, nice simple file, and it explained that not all transformers are created equal, all right? And then I found another one that said transformers can be 99% efficient. That's what I was taught in school. They say 95 to say, but when a transformer is designed for a specific purpose, like a filament transformer, under the three, in this case, this one here, when this thing's being, you're drawing 3.3 amps from this transformer, it's going to go down to 12.6. Okay, you power one of these up, put a meter on it, it'll read maybe almost up to 14 volts. Okay, and then as you increase the load, it drops. It's made to do that. Now, if you go reverse with that kind of transformer, the shit's going to hit the fan. You're going to have losses. Even when the transformer is just hooked to the other one running, nothing on the output of the second transformer, you're going to have, in my case, I was measuring 500 milliamps loss, and that's half an amp. Okay, and I was like, what the hell's going on? Why do I always find these things? Okay, now I went looking, I found a file where guy speaking broken English, guess his instructor told him you can't do it, and he couldn't figure out why you can't get the same amount of energy through transformers out the other side as what you have on the input of the, he didn't understand losses. He's one of those perpetual motion free energy guys. You hook up a bunch of transformers and you end up getting more voltage out than you put in, but unfortunately it's at less current, and people do not understand the difference between voltage and current. If you show someone, look, 120 volts, now it's 180, and then you do the math, like the second transformer has the same current as the first transformer, it's free energy. Look, I'm getting extra amps, I'm getting extra wattage. No, you're not. The second transformer It's going to have a higher voltage when you're stepping up, but it's going to have less current. So it's the same amount of wattage, approximately. And then you got the losses of the transformer. You also got what kind of transformer are you using? Are you using a transformer that's meant to be backfed? Okay? If not, you're going to have that problem I just explained to you, that it's wound so it'll be 12.6 volts under a full 3 amp load. Okay? So I did learn something in this, but this turned out to be just, these smaller transformers are more efficient, and backfeeding it worked. And the fact that I used a 24 and I used a tap, the center tap to the outer side to get 12, backfeeding this 12, and the reason I did this for size, the fact that I used a smaller transformer over here gave me more room to put my power supply in there, or my full wave bridge, and 2 capacitors and a resistor. Okay, this took a lot of thinking to build this little unit that drops on the back. Got a connector. I showed you this a million times before. Okay, and then I tried to use the same system to make voltage for the BC348, and my transformer was getting red hot, and it wasn't. There's no thermals. There's no thermal breakers in the old ones, so the transformer just got hot. I think that's it. I hope you learned something. All right, that's it.